I'm sure you've heard that a lot of students are using AI to do their homework. But what does that really mean? Does it mean that they're using it as a tutor? Does it mean they're using it as a study buddy to make quizzes and flashcards and practice questions? Well, I'm a high school teacher, and in my experience, it usually just means they take a picture of it, they ask AI how to do it, it gives them answers, they copy it down, and sometimes it'll even show the work of how to get to the final answers. The issue is that this is not what real learning looks like. I'm finding that students know less and less of what they're showing they can do because they copy down the steps without understanding what they're doing. The issue is that AI is really good at making things look nice and neat and clean, but learning is messy and frustrating and difficult. True learning requires some amount of friction to learn new concepts, to orient new ideas in your head, and to learn new definitions. So today I'm going to show you what it looks like to truly use AI as a study buddy, as a tutor, and not just as the vending machine that gives you answers. I'm going to be using my iPad and Gemini. Let's see what it looks like. Let's assume that you're a tech-savvy student who has an iPad and knows how to use it for school. I have my chemistry review for my upcoming test on gas laws, and I want to use Gemini as a tutor, not just as someone to tell me the answers. So what I'm going to do is I'm going to start a Gemini live session. I can share my screen to Gemini Live.
To share your screen with me live, just look for the screen sharing icon at the bottom of your screen while we're talking, or try holding down your power button and tapping Share Screen with Live. Does that help?
It does. Can you see my screen right now?
Yeah, I can see it now. Looks like you've got a gas laws review worksheet open. Ready to dive into it?
I am. So there are two things I want you to do. I want you to help me identify deficiencies that I have as I'm studying for this test. I want you to use the Socratic method to help me work through this. How does that sound?
That sounds perfect. Using the Socratic method means I'll be asking you questions to help you figure things out on your own. Where would you like to start on this worksheet? Maybe with problem number 1?
Yeah, I think problem number 1 sounds like a good start. It says a gas occupies 2.5 L at 1.2 ATM and 300 K. What will its volume be at 0.95 ATM and 350 K? Okay, where should I start with this?
Okay, let's start with what we know. To get a clear picture, what are the initial conditions for the gas, like its volume, pressure, and temperature? And what are the final conditions it's changing to?
Well, I see a few letters. I see 350, 2.5 L. I see 1.2 ATM and 300 K. I see volume. I see 0.95 ATM, and I see 350 K. I think I remember that K means Kelvin. I think L is liters, and ATM, is that atoms?
You're right that K is for Kelvin, which is the unit for temperature, and L is for liters, for volume. Standard units for these problems. ATM stands for atmospheres, which is a unit for pressure. So given that, what variables are changing from the beginning to the end of the problem?
Well, it looks like all three are changing. It looks like my volume and my pressure and my temperature are changing.
You're absolutely right. All three are changing. Since you have a change in pressure, volume, and temperature, which gas law connects all of those together? Take a look at the hints on your sheet if you need to.
Well, I'm looking at this. It looks like if pressure, volume, and temperature are changing, it should be the combined gas law. And it says the formula for the combined gas law is this one over here. This PV over T equals PV over T. How does that sound?
That's exactly right. Now that you have the right formula, which number should go where? Which one's your initial pressure, initial volume, and so on?
Well, I'm going to assume that this yellow set of numbers and this green set of numbers go together. So if I were to plug it in, let's see, how do I know which one's which?
That's a great assumption. The yellow group are your initial conditions, so they'll go on one side of the formula. Based on the units you labeled before, which one represents the starting volume, pressure, and temperature? The green group will be your final numbers, what you're changing to.
So you're saying I should look at the units to figure out which one's which. Well, looking at that, I guess my initial pressure would be 1.2. My initial volume would be 2.5 divided by T is 300. That's equal to my final pressure is 0.95. My final volume is my unknown, and my final temperature is 350. How does that sound?
That looks perfect. You've plugged in all the initial numbers on the left side and the final ones on the right, with volume 2 as the unknown. Now it's just a matter of solving for that unknown volume. What's your first step to get volume 2 by itself?
Well, if I want to get volume 2 by itself, I want to get rid of this 350. So what if I subtract 350 from both sides? So I would get 0.95V equals 1.2 times 2.5 over negative 50. How is that?
I see what you're trying to do, but since the 350 is currently being divided, subtracting it won't quite cancel it out. Think about the opposite operation. How could you move the 350 to the left side of the equation by multiplying instead?
Oh, right, because I'm dividing by 350. So if I want to do the opposite, I would have to multiply by 350 so that it cancels out. Then I multiply by 350 over here too, right?
Yes, that's exactly right. You'd multiply both sides by 350. Now that the 350 is cleared from the right, what's left on that side? And what's the next step to get volume 2 by itself?
So I have 0.95V equals 350 times 1.2 times 2.5 divided by 300. You said I need to do the opposite of what I'm doing. It looks like I'm multiplying here. So I'm going to subtract. Minus 0.95 minus 0.95 leaves me with V is all of this minus 0.95, right?
You're right that you're multiplying, but again, subtracting won't quite cancel it out. The opposite of multiplying by 0.95 is dividing by it. How about you try dividing both sides by 0.95? That should leave the final.
Well, I don't really get that. Why am I supposed to divide by 0.95? Why does that make it go away?
That's a great question. Think about it like this. Right now, 0.95 is stuck to the V because of multiplication. To separate them and get V by itself, you have to undo that multiplication. Since the opposite of multiplication is division, dividing by 0.95 essentially makes it cancel out on that side, turning it into 1 times V, which is just V. Does that make a little more sense?
Yeah, I guess so. All right. Now I'm going to do just some estimation. Call that 1. I'm going to assume this is a little bit more than 4 liters.
Yeah, that's a pretty good estimation. So when you calculate all of that, you get a final volume of around 3.68 liters. Does that number sound reasonable to you?
Yeah, it does. Just doing a little mental math here. Okay, well, you just worked with me for a few minutes. Could you make me a list of a few things I need to work on based on our conversation? What are some of the fundamental things I should get down for our next conversation?
Sure. Based on that problem, I'd say focusing on basic algebra for solving for variables is key, especially keeping units consistent. It might also be helpful to review when to use each gas law, like we did with the combined law here. Want to try another problem and keep working through those?
Is there anything else that I should work on? Maybe some definitions or specific skills that I need to learn?
Definitely. You might want to make sure you have a solid understanding of definitions for pressure, volume, temperature, and the amount of gas particles. For skills, practicing converting units between things like Celsius to Kelvin or milliliters to liters will be really helpful. Also, just reviewing the basic idea behind each of the gas laws we mentioned before could help you decide which one to pick for a problem. Does that sound like enough to focus on for now?
It does. Are these some things you could make me some extra practice for? How about making a Google Doc that has practice for those items?
I can't create a Google Doc directly, but I can definitely whip up some practice problems for specific skills like unit conversions or algebra right here. Which one would you like to try first?
You know what? I think we can come back to it later. Thank you so much, though. That was really helpful.
You're very welcome. Whenever you're ready to come back to those practice problems, just let me know. Good luck with your studying.
So, what you just saw is what it looks like to have Gemini actually walk you through your homework as a tutor. And while it's not perfect, AI is getting better exponentially. And so I'm sure that there will be a point in the next year or two where it really is almost like having someone work through it with you. And I'll say, I was making some pretty egregious mistakes on purpose, and it caught every single one of them. It corrected me gently, it told me what to do, and it didn't get frustrated when I made the same mistake twice by subtracting instead of dividing to get rid of the multiplication. So what's the practical application? I spent $350 on the iPad, the Folio case, and the Apple Pencil, and the Gemini year-long subscription I use is $20 a month, so $240 a year. Okay, so $600, give or take. You might say, whoa, that's really expensive. But when you think about it, how much does in-person tutoring cost? $50 an hour, $100 an hour? I've heard it go up to $200 an hour. So you're getting an iPad and 24/7, 365 personal support, or somewhere between 3 and 12 hours of in-person tutoring. I don't know. For me, that's not a tough decision. I would rather have the autonomy over my time, my information, and I'm also investing in hardware and software that's able to help me in more than just tutoring. I can use this for work, I can use it for school, I can use it for any number of my productivity tasks. So, is this what education is going to look like in the future? Is it going to be individuals that have AI tutors and then just maybe facilitators that bridge the gap? Or is it still going to be heavily reliant on teachers? Or is it going to go just completely independent, asynchronous? As we're already seeing with a lot of higher education institutions, people are finding that you can do the asynchronous thing pretty well. If you have a self-motivated student, they can learn a whole lot with a good tutor. But there are some people where they still need that extra push of a human who's there to regulate them and physically be there to encourage them and spur them on and be more than just a talking screen. These are all questions that we're going to have to wrestle with in the coming months and years and decades, but they're important that we sit down and start talking about it, because otherwise we're just going to get steamrolled. So I hope that this video was maybe inspiring or encouraging or thought-provoking for you. And I have a series of other things I want to talk about, of like how to actually set up a digital ecosystem where you can have this happen, because if you don't know how AI works or how an iPad works or how the file management works, that may just seem like magic to you, but they're all fairly simple systems that work pretty well together for the most part. And this is what I'm interested in helping people figure out how to do, finding systems of technology that work for them to help them do the things they want to do and to minimize any barriers that would keep them from accessing information or education or just productivity. So if you have any questions, feel free to hit me up, and have a nice day.